Hello, now we're going to continue on with our work in sets, and we are going to be looking today at the idea of an empty set, which we'll call a null set, which is an important idea, and then we're also going to be looking at the idea of subsets, which is sets within sets, so groups within our bigger groups. Now, we're going to start off with the idea of an empty set, and an empty set is exactly what it sounds like. It's a set, a group, that has no elements in it, and it's an important idea for our more foundational definitions, but for right now we need to just be very clear on what it is. So the empty set is called in maths the null set, and it has our two symbols here. Unfortunately, it has two different names in mathematics. We have a 0 with a line through it, and we'll come back to that in a moment, and we have one that might be a little bit easier to empathize with. We have curly brackets with no element written inside. Now it's important that we immediately think about the fact that this here is not an empty set. Why is it not an empty set? Because it has the element number 0 in it. So 0 is a number, and if it can be part of a group. So a common issue that students have is that we think, well, 0 means nothing, so the empty set is going to have the number 0 in it. But 0 is a member of a group. It's a number that we can write down. So that is not an empty set because it has the number 0 in it. So that's not our empty set. Our null set or our empty set is just curly brackets with nothing inside. Now, if we come back to the other symbol that we use for it, a 0 with a line through it, why don't we just write down 0? Because we're talking about a set. And when we're talking about a set, we're not talking about a number. So we can't just write down the number 0 because it's not a set. So we put a line through it in order to indicate that it's a different idea. 0 and the empty set are connected ideas, but they're not the same, so we can't use the same symbol for them. So what we've got is the idea of an empty set, a set with no elements in it. It's called the null set in mathematical speak, and these are our two symbols for it, a 0 with a line through it, or just curly brackets with nothing in them. And we need to know both of these symbols. We're required to know both. Now if we look for an example of where we might get the empty set, we'd look for where we have a definition that has a contradiction in it. Is often a way that we'll get it. So the months of the year starting with the letter Z. Well, there are no months of the year that start with the letter Z. So we would just say, we'd write our curly brackets and we'd put nothing in there because there's nothing to put. There are no months of the year that start with the letter Z, so our list of elements is non-existent. There's nothing there, so we write our curly brackets with no elements inside them. And we also need to know that we could see that symbol, our 0 with our line through it, means the same thing, and we need to know both ways of writing it. So this is the idea of our null set. It's just a set that contains no elements in it. And if we have that, then we're okay, and we remember that the null set means we've got no elements in our set. And it is a fact that we're going to have to keep in mind that because of the way we define groups in maths, we say that the null set, our empty set, is a subset of all sets. Well, what does a subset mean? It means a smaller group within our bigger group most of the time. So here's our work on our subsets now. We have a subset is a set within a set that is contained within another set. So we would say that a set A was a subset. This is our C with a long arms on it. So it's like C with long arms on it is our symbol for our subsets. That's what our subset symbol looks like. And A is a subset of B if all the elements in A are in B. Now let's look at what that would look like if we list all of the subsets of the set L. The set L we've talked about before is the first 3 letters of the alphabet. So let's write down L. Anytime we're doing a problem in maths, make sure that we write down the information that we need at the beginning. So I've been asked about the set L, so I'm going to write down the elements of the set L, so I have them right in front of me, and now I can start to do my work. Well, I want all of the sets that it would have the elements of L within it. So I told you before that or just a moment ago, that the null set is considered a set of all sets. So the null set is going to be part of our list. So what I'm going to say is, to begin with, I'm going to talk about the subsets that have 0 elements of our set in them, and that's always going to be the same. That's going to be the null set, and I just have my curly brackets with nothing in them. Then I'm going to look at subsets that have 1 element in them. I know that my symbol here means element, so one of the elements of my set here. So I'm going to be looking for subsets that have 1 element. Well, one of the elements in the set L is A. So I could have a subset of L would be A. All of the elements in this set are in the set L. So it is a subset. Another subset of the set L that has 1 element in it would be the set that has B in it. And a third one would be the subset that has C in it. Again, we have 1 element from the set L in our 3 sets here. A is in L. A is in the set L. So all of the elements in this little set here are also in L. So this set is a subset of the set L. Then if we list out all of the subsets that have 2 elements from L in it, we'd have A and B. We would have another subset would be A and C. And we'd have another subset that would be C and B, or B and C. Our order doesn't matter, as we already know. Now, because the order doesn't matter, I actually stop at this point, because if I wanted to continue, I might write something like the subset B and A. Why wouldn't I bother writing that? Because I already have the subset A, B, and I know that the order doesn't matter. So I'm not going to rewrite this first set by just changing around the order, because it's the same set. I know that the order doesn't matter in a set, so AB and BA would be exactly the same set. Now I'm going to write any subsets that have all 3 elements of the set L. So that would just be the set A, B, C. And this is a subset because every one of the elements in this set are also in L. So any set is a subset of itself, because all of the elements in this set are also in the set L. And that's how we're going to list out all of our subsets. We're always going to start the same way, listing our null set as the one that has 0 elements from our set. Then we're going to write out all of the subsets that have 1 element from our set, all of the subsets that have 2 elements from our set, all the way up to however many elements there are in our set. And you can see that if we had a big set, we would end up with a huge number of subsets. The list would get very long. So that's the idea of our subsets. All of these are subsets of the set L, because the elements in each of these sets are all in L. Now if we look at our 4 examples down here, we have the set F, we have the set G, we have the set H, and we have the set I. So let's see if we can write down anything about subsets here. So let's take the set F. I'm going to ask a question. Is F a subset of G? Remember, a subset symbol is where we have our C with long arms on it. Is F a subset of G? No, it's not, because the elements of F are 1 and 2, and the elements of G are 2, 5, and 7. And the element 1 is not in G. So all of the elements in F are not in G. So it is not a subset of, F is not a subset of G. So we would write down, no, F is not a subset of G. Now, if we think back to when we were talking about elements, how did we say that something was not an element? We put a line through it. And we're going to do the same thing with subsets. So we have F is not a subset of G, because all of the elements in F are not in G. Let's ask another question. Is H a subset of F? Is H a subset of F? Yes, it is, because all of the elements in H are in F. So F or H is a subset of F. But we can actually say something else about them, can't we? Because we don't care about the order of our elements in our set. So we could actually say that they are equal as well. So they are subsets of each other. That's perfectly true. But H is also equal to, is the same as the set F, because we don't mind about the order that these things come in. So this set is actually identical to this set, because we don't mind what order our elements come in. Next, is I an element, is I a subset of H? And yes, it is. I is a subset of H. Why? Because 1 is the only element in I, and 1 and 2 are the 2 and 1 are the elements in H. So all of the elements in I, 1, are in the set H. So I is a subset of H. So we have seen all of the different things that we can do now. We have the idea of an empty set, a null set, and we know that it's a part of a subset of all other sets. And we have the idea that a subset is a part of a set, and we have A would be a subset of B if all the elements in A are in B, and we've seen several examples of how that can work. So we have the idea of a null set, an empty set, and we also have the idea of subsets. And those are the tools that we need for solving our problems right now.